Here's an algebraic problem using an equilibrium expression from a balanced chemical reaction. In this example, we have our balanced chemical reaction, the combustion of methane gas, and here is our general equilibrium expression with the products on top, reactants on the bottom. In this case, we know the value for K, 13.24. From in previous experiments, you measured everything and got a value of 13.24 at a constant temperature every time. Okay? Now imagine that one day you run this experiment and you measure 3 of the 4 molarities. You measure the molarity of your reactants at equilibrium, but at equilibrium, you can only measure the concentration of CO2. Remember that square brackets mean molarity. So these numbers here are not unitless. They have the units of molarity. That's what square brackets around the chemical formulas hieroglyphics for. This is a substitution or solve for X type problem. O2 at equilibrium has a value of 0.5. CH4 has a value of 1.15 at equilibrium. CO2 has a value of 1.5 at equilibrium, and H2O is our X, or unknown. And for right now, I'm just going to put that in there as an X because I think that makes it easier to digest from a math perspective. Okay? And we only have one unknown. K equals 13.24. Let's solve out the denominator because I can solve for everything in there. And just note that these numbers are ones I just kind of made up for the sake of argument. And this number is up top here. This is x squared times 1.5. Now I have to rearrange this thing. I'm kind of across the board here. I got the 13.24. So I can take this number and kind of multiply both sides of the equation by 0.2875. I'm going to do this on this board here because I think it's a little easier to see. 13.24 equals 0.2875 times x squared 1.5. So I'm going to get that stuff over there. Multiply both sides of the equation by 0.2875. I get 3.8065 equals x squared times 1.5. So to get x by itself, I'm going to divide each side by 1.5. I have 2.537 equals x squared. So to get the constant, remember x squared started out as the concentration or molarity of H2O. I'm going to take the square root. This is an algebraic problem where you are given a balanced chemical reaction and asked to solve for the unknown. You isolate, rearrange, multiply, and divide what you have to. And at the end of the day, we get this molarity of water to be 1.59. at equilibrium. A great way to double check it, check your answer, because the multiplication divides and the square roots, is just to plug it back in, because this right here should equal 13.24, close there too. Thank you.